Today we are going to see the eating the candies. That is the Codeforces around 784 F solution. So, like in short, I will give you what is in the question actually. So, uh, there is an array of the candies. So, Alice will start eating from the left side, and the Bob will start eating from the right side. So we want to tell that uh, how much maximum candies they can eat together, so that the conditions like uh, Alice eats the same candy as the Bob in comparison of the weight. So there is a weight of ith candy given in the question, so that whatever they eat, their weight should be the equal. uh, So see, Alice can eat the number of the candies from the left and the Bob starts from the right. So their goal is to eat the total weight of the candies. We have to give the most number of the candies. So in the I have solved using the two-pointer approach as well as the binary search solution. So let's discuss the first two-pointer approach. So uh, here we have the left pointer over here and the right pointer over here. uh, like if left is equals to right, so that this could be my possible answer as well. Answer 1 second. Answer 1. So why like answer 1? So uh, let's say I will first redraw everything. Okay, so the weight is like uh, at let's say at this point, uh, having 1 2 3, again 1 and 1. Suppose this is our array. So here we have the left pointer and we have the right pointer. We cannot sort actually. If we sort now, so the order becomes the invalid. So the thing here is, when we are at this point, left is equals to 1 and right is equals to 3. So we can move the left pointer so that our weight becomes the equal. So we move the weight, so then my weight becomes like 3, the sum of the weight actually, from the left side and from the right side. So here for weight we will going to maintain the prefix and the suffix array, so that we cannot confuse with each other, so that we get the weight as per. So here we got the weight, but uh, the total number of the candies is 3 only. But if we again move the left pointer over here and the right pointer over here, so their sum will equals to 4, both L is equals to 4 and R is equals to 4. Their weight is equal, but the candies is 5. The total number of the candies they eat is 5. So our answer is the 5 only. So this is only the two-pointer approach. Let me show you my code actually. uh, so here it starts from here. I have input the test cases for each test case. I am inputting the n value and the vector array, like the array for the weight array. I have maintained the prefix and the suffix array as well. Prefix is used to 0. This is the prefix code and the suffix array. You can pause the video and see what I have done actually. And here we will maintain the left pointer and the right pointer. And one more thing, left and right cannot be equal. So why it is this here it is mentioned in the here itself. If Alice eats a candy, Bob cannot eat, and vice versa. If left pointer is taken by A, the right pointer will not taken by A. So we cannot do like so both pointers cannot at the same position L and R. This is not valid actually. So let's see the question. uh, let's see the code over. So I pointing to the 0th and r is on the n minus 1, and for answer, for like how much count I need to take, like answer 1 answer 2 among the maximum of all the question. So while left is like less than r, prefix of left plus prefix of the right. So like if both of the prefix, then it is actually um, uh, this is the like right part, like left plus 1, and we are adding n minus r. So let me tell you why I have done this. So next page. So like suppose this this is my array, total elements 0 1 2 3 4 5 6 7 8. So my n is equals to 9 actually, and my left here pointing here, and left and right, suppose this is pointing me over here. So why I have taken, so as you can see here it is the left part and here it is the right part. uh, why I have done the left plus 1, because see here I have left is equals to 3, but in total we have eating the 4 candies. This is because I have started with the index 0, so that is left plus 1. So this is the uh, left part, so int left part equals to l plus 1, because I have started with index 0, and my right part will become like n minus r. So this is part. Alright, you have like, I think you have understood the question, and after this I will sum sum up the both of the things. Left part I have maintained only the one counter, actually count, taking the answer is equals to maximum, and and we are incrementing left pointer and the right decrementing the right pointer. So after got this as this much value, uh, in future maybe I got in some other value which having the equal uh, weight value, uh, weight value is to be the equal, and count will be always the maximum. uh, so I have increment, and if my uh, left part, like the prefix of the left is greater than the prefix of the right, so like my left part is greater and right part is smaller, then I have to decrement, I have to add more things on the right side, so I have to decrement the right pointer. That is what I have done, decrementing the right pointer. And else if prefix of the l is less than suffix of the r, then I have to increment l pointer, and after that I have to do like print the answer. So it is giving me the correct answer, as you can see, accepted. So let's see the binary search solution actually, that is the main thing. um, for the binary search solution, let me show you directly the code. This is the two pointer approach, and this is the binary search solution. What I have done for the binary search is like, I have the array, this is my array. I have calculated previously, I have calculated all the prefix sum, and for like binary search, what I'm trying to do is like, uh, it eat the bob candy first, and then calculate at what index they are equal, like 0 to n minus 1. So this becomes my the search space. If like, see, as you can see, I have calculated the prefix sum of all these things, then uh, how much weight that Bob can eat. So I am starting from n minus 1 till I greater than 0, and I am decrementing the, like, this is the inverse for loop. I have add the current weight value to the Bob element. So and my search space becomes L is equals to 0 and R is equals to I minus 1. uh, so if Bob eat this much candy, then my search space becomes this much only, 0 to I minus 1. Suppose this is I, so this becomes I minus 1. This becomes I minus 1, and here left is less than equals to right. Then I am applying the binary search for this. If prefix of the sum, prefix of like calculating the mid value, then I will check like okay. So let me explain. If Bob eat this, the search space becomes like this, calculating 0, 1, 5, 6, and 7. So 3 approximately, like over here my mid value is like this. uh, Calculating the mid value and taking like if Alice ate this, will Bob able to eat like this much. So we are comparing this much weight with the current Bob eating the weight. So I hope you are going to understand this. If prefix of the mid, like if this value till that this value is great, like I am going to explain this in a better late, it is the easy part to understand this. Prefix of the mid is greater than the Bob, so like if this value is greater than the Bob value, then what I have to do, I have to add more in the Bob. So I am so my um, R is equals to, like I have to decrement the mid actually. R is equals to mid minus 1. So for the particular value of the Bob, I am calculating whether it is possible to get the equal amount of the left part, the weight of the left part actually. So as you can see, I am decrementing, and similarly for the inverse, like vice versa. And here I have calculated the left part and the right part, as I previously mentioned in the uh, two pointer approach. But before that I will calculate the index, like taking the mid. If it is equal, then it may be one of the possible answer, taking the maximum of the answer plus left part plus right part, and incrementing the left index by mid plus 1 actually. So my search space becomes like lower. So this solution comes like n, okay, n log of n. So this is my solution. And if we're talking about the two pointer approach, it's just a O of n approach actually. So two pointer approach will definitely be the better site actually, rather than the binary search. So hope you understand the question. If you don't, then please comment on. Thank you.